anything means a variable that was passed in through the query string in the browser. Form.anything was passed in the post data of an HTTP request. Cookie is probably pretty obvious. Flash comes from the Flash movie. CGI, not all of the CGI scope variables are tainted, but most of them either are tainted by default or can be easily tainted. And we'll have a slide on that later. And then some of the scopes are going to be tainted depending on how the application was written. So we talked about session scope variables or request scope. And those can be entirely clean. So the session scope could be entirely clean or could be entirely dirty, depending on what the application developer did. They may use the session scope as a place to put stuff. They may copy every URL variable, for example, into the session scope. That's a bad idea, but they may do it. So you have to look at each one of these individually to see if it's tainted. Client.anything. This is another case where you have to look at how the application is configured. So if they're using cookies, then obviously anything in the client scope is going to be tainted because cookies themselves are tainted. But if they're using a different mechanism for the client scope, such as using the registry on the server side, then those are not going to be tainted because the end user of the application can't go and control the registry. And then finally, arguments to CF functions, which are defined with access remote. Brandon was talking about that earlier, where you could access CF functions without authentication, just using the URL and a special syntax for doing so. If the access is set to remote for that CF function, then you have to consider all the arguments to be tainted. So this is a relatively complete list of all the places where you would look for untrusted data in entering a ColdFusion application. And that's kind of as good of a starting point as any when you're looking for these types of vulnerabilities. So keep that in mind. We have a few slides on cross-site scripting. Because cross-site scripting in ColdFusion is very complicated, and kind of a side effect of the design being simplified for non-developers is that you have a lot of mechanisms built in that do similar things, but they don't do it completely, or they overlap in certain ways, and nothing actually provides a full defense against cross-site scripting. So there are a few different suggestions that are made in the developer documentation to help protect against cross-site scripting. And one of these is this attribute they have called script protect. And this is something that can be set up at the application level. We have some example code there. So CF application script protect equals all, and that will just say turn on this script protect mechanism for the whole application. And the way script protect is described in the documentation is it says it will block most attempts of cross-site scripting. And there's not a whole lot of information beyond that. What it actually does is it looks for a script. It looks for the literal open bracket script in user-provided data. And if it sees open bracket script, it will replace it with open bracket invalid tag. So that way, if you're injecting that type of cross-site scripting attack, such as just script alert foo, ColdFusion server is going to see that, and it's going to replace that open bracket script with open bracket invalid tag. And obviously, when the browser renders that, you don't have matching script tags, and the alert is not going to actually execute. So nothing will happen. And script protect looks for script, it looks for object, it looks for a couple others. I think there are two others, but basically it's doing the same thing. It's looking for those special tags, and it's replacing them with invalid tag. And this is supposed to protect against most instances of cross-site scripting, which is a complete misnomer, because it's absolutely trivial to circumvent. For example, if you take that same vulnerable code that we did earlier that says you typed url.foo, and so obviously you just pass in something on the query string, and it gets printed out to the page. Well, instead of using a script tag, just use an image tag. Image isn't blacklisted, so it happily passes straight through script protect, and it loads that image there that's in the source tag, and as soon as it's done loading the image, it'll run alert foo. And this is just one of many examples. Because it's a blacklist, you could use basically any tag that accepts an attribute that can contain JavaScript. So this is really, really easy to circumvent, yet it's touted as this major defense. You can mess with the blacklist if you want. You can go into this XML file that is packaged with the ColdFusion war, and it's called neo-security. And it's regex syntax, and it shows you exactly what it's looking for and what it replaces stuff with. But at the end of the day, it's still a blacklist, and a blacklist is not the right way to protect against cross-site scripting. So bottom line is, Crystal Script Protect doesn't hurt you, but it really doesn't help you that much either. So like most programming languages, ColdFusion gives you a few APIs that you can use to do HTML encoding. And the two that they give you are HTML edit format and HTML code format. And those take the input that's given to them, and they replace open and close bracket, double quote, and ampersand with the HTML entity equivalents, which will prevent some cross-site scripting attacks from succeeding. However, they don't encode single quotes, and for any attributes that are unquoted or single quoted, or something that's already within a script block, it's not going to help you. If you are familiar with the OWASP XSS prevention cheat sheet, you know that encoding has to be done on a contextual basis. You have to look at where the data is being used in the context of the page and encode it depending on whether it's in a tag or it's in an attribute or a script section or a URL, and you have to apply the right type of encoding. And here we have kind of a one-size-fits-all solution. They say use HTML edit format, and it will encode those characters, and that's it. There are 4 examples of cases where you might use HTML edit format and it would not protect you at all, because there are either no double quotes to escape from, or you don't have to worry about brackets or anything like that to get the attack to actually execute. There's another API that they have called XML format, and it's the same as HTML edit format, except it also encodes single quotes. So now you get encoding of 5 characters instead of 4. So XML format is actually better than HTML edit format in just about every situation for protecting against cross-site scripting. But it's still not a complete one-size-fits-all, because you have to worry about situations where you're printing the output to an area of the page that's already in a JavaScript block. So again, that needs to be a contextual approach. There aren't really any other encoding functions that are suggested to be used here, at least provided by the framework. So you have to write your own. And generally, XML format is going to be better to use than HTML edit format. But the way it's named is so misleading, because the developer, so if somebody is not familiar with security or doesn't really understand what's going on, they're not very likely to use a function called XML format when they're writing an HTML page. Even though it's going to be better, it's going to encode more characters, a developer who's not kind of security aware is going to be less likely to use it. So it's a little misleading in that sense as well. So let's say you've gone to some security awareness, security development training, and you learned all about how blacklists are bad and whitelists are good, and you should always whitelist your input to make sure that your application is getting what it expects. And you have some code, like one of these ColdFusion expressions. The first one, for example, let's look at CF output. And you're passing a parameter in the query string called count, and it's supposed to contain a number. So you're taking all this, all this knowledge that you've gained through the security course, and you say, well, I should whitelist this. I should make sure that this is an integer, because there's no reason this should ever contain a word or special characters or anything like that. So you use the int API call, which is essentially like a cast. And you cast URL.count to an integer. And you say, well, that's going to protect me if somebody puts words in there, if they put cross-site scripting string or anything that I don't expect. And those other 2 examples are similar, right? Number format is a ColdFusion expression that does essentially the same thing. Java cast, you can cast a variable to a Boolean in that case. But they're all examples of doing some kind of whitelist checks. Well, what happens if, in that first example, you provide the variable count and you put something in it that's not a number? You're going to get this default error page from ColdFusion that looks like the graphic on the page here. It's going to say the value foo, if I supplied the word foo on the query string, the value foo cannot be converted to a number. And there's some developer information there, verbose debugging information, and so on, to help you figure out what went wrong. The problem here is that, as you can see on the error page, you're actually printing out the value that couldn't be cast. So if you, for count, if we just put in a cross-site scripting attack vector, then that is actually going to get printed out on the error page, and it's going to cause cross-site scripting. So it's ironic because you tried to do this whitelist validation, and actually by doing so, you caused an exploitable scenario through this default error page. It's worth noting that on the default error page, script protect is always enabled at the runtime, but we already saw how it's easy to bypass script protect, so it's almost not even worth mentioning that it's enabled. So you're trying to do the right thing, and you create an exploitable condition, and that's not documented anywhere. So let's say you don't use the default error page, because let's face it, most applications, by the time they reach production, maybe sometimes somebody has told them not to use a default error page, maybe not for security reasons, but just because there's so much information displayed there, and it doesn't look pretty, or whatever the case may be. So you can define an error handler page that takes over when an error happens. So there's a CF error tag that you can use, and it says, if an error occurs, call errorhandler.cfm instead. That way, you won't get the default error page. It'll just redirect you to errorhandler.cfm. And then that page has access to an object called error, which you can then use to print out information about what happened, but you can do so in a pretty way. However, when you do that, you can still make some mistakes. So like I said, you have an error object, and you can start printing out various members of that object that give you information on what went wrong. And one of those is error.diagnostics, and one of those is error.message. And both of those also contain the attack string. So if you have your custom error handler, you're not using the default error page, you define your custom error handler to avoid the problems with the default page. And on your custom, your pretty error handling page, you print out, sorry, you threw an error occurred, here's what happened, and then you output error.message. You've just caused cross-site scripting. Again, you can also use exception handling. So you can use typical try-catch blocks, similar to other languages that are out there. There are CF tags for that as well. And when you're in a CF catch block, you have access to an object called CF catch, and that also has different fields that you can print out what happened. And the CF catch.message field also contains the attack string. So if you're doing any of these things for error handling or exception handling, and you're not aware of which fields contain tainted information, you can end up still causing cross-site scripting to occur on the page. So ColdFusion is fraught with all sorts of pitfalls that you can make with cross-site scripting. And as you saw, the defenses are incomplete, the documentation is incomplete, and no wonder it's so easy to find cross-site scripting when you're pen testing a ColdFusion application, because it's just not easy to protect against, let's face it. I mean, there's just too much going on. We have a little bit on SQL injection just because there is one behavior that I wanted to point out. We won't dwell too much on this, but this is an example of what a SQL query looks like in ColdFusion. They have a tag called CF query. You give it a name, you point it to a data source. The data source is configured on the back end in the server before the application even starts running. So you have a CF query tag, you tell it what to query against, you put the query in there, and then as you can see, you can use CF expressions inside the query tag to populate